All right, good morning. I am going to go over section 5.5 homework with y'all. This is on the derivatives of the logs. So let me get this stuff straight so I can pull it up. Okay. Okay. Now the derivative of the logarithm is a little bit different from the derivative of the natural logarithm. If you remember, the derivative of the natural logarithm is simply 1 over x dx or 1 over u du, or you can simply think of it as du over u. Now with your logarithms though, it's the natural log of that base times the function itself. And so the derivative of the first one is really easy. It's just natural log of 5 times 5 to the x. So if you were writing it by hand, that would be fine. In WebAssign, we're going to have to, have the open parentheses on the 5, close it, and then 5 to the x. And truthfully, the order that you write those doesn't really matter. We just normally put that coefficient first, the ln 5. So let me get that answer in there. Okay. So our second problem is x times 6 to the x. So we're going to have to use our product rule. All right, so f prime, we have high d low, so that's going to be the first times the derivative of the second, or d low, and that's natural log of 6 times 6 to the x, and then plus low d high, which would be 6 to the x, and then the derivative of x, which is just 1. Okay, you could, take away the 1, of course. You could leave it like that, or you could factor out your 6 to the x, and that would leave you with x, natural log of 6, plus 1. All right, and that's probably how you would see it on a multiple choice test, as opposed to, if you're just writing your answers out. And of course, WebAssign will take it however you want to put it in there, as long as it's mathematically correct. You have to watch with all these parentheses. Make sure that for every open parentheses, you have a closed parentheses. Okay. All right, so number 3 is a little bit different because now we are dealing with a logarithmic function. So the derivative of a log is kind of the opposite of what we just did. Instead of multiplying by the natural log of 4, we're dividing by ln 4. And you can see, the proof and where these came from if you just, read through your textbook, your e-text. Okay, so y prime is 1 over the natural log of 4. And then times that argument, that goes on the bottom, x squared minus 9x. All right, now you multiply that by the derivative of your argument. You have chain rule here. So we have to do the derivative of x squared minus 9x, which is 2x minus 9. Okay, so clean that up a little bit, and really all you can do is just put your 2x minus 9 on top over the natural log of 4 times x squared minus 9x. All right, so that's pretty much it for that problem. Okay, so remember your chain rule. And remember that taking the derivative of a log is going to be 1 over the natural log of your base, and then times that argument, but the argument goes on the bottom. All right, so we need 2x minus 9 over ln 4, and then x squared minus 9x. All right, and we just have one more on this section. So this was a pretty short section for homework, considering. All right, now with ones like this, that they're logarithm functions and they contain products and quotients and so forth, square roots. What you can do is use your log properties to expand it, and it's going to be a lot easier to work this problem. Otherwise, you're going to be using, the product rule, the power rule, possibly chain rule on this one. Yeah, well, not so much chain rule, but anyway, too many rules. So what you want to do is rewrite this function, and that's what they tell you in the hint. In some exercises, you may find it helpful to apply logarithmic properties before differentiating. Okay, so that's what we're going to do. All right, so to break this up, we have log base 8 of x. So remember, the log of a product is the sum of the logs. So anything multiplied is going to be added. Anything divided is going to be subtracted. So that's log base 8 of x plus, and then our square root is really to the 1/2 power, and you can bring your power to the front, your exponent. So 1/2 log base 8 of x minus 3. And then that 8 is being divided, so anything divided is going to be subtracted. So it's minus log base 8 of 8. And if you know your properties of logs, that's really just another name for 1, because 8 to the first power gives you back 8. Doesn't really matter because it's a constant, and so the derivative of a constant is 0. Okay, so now I'm going to take my derivative. So the derivative of log base 8 of x would be 1 over natural log of 8. Sorry about my pen. It does these crazy stray marks sometimes. So 1 over natural log of 8, that's going to be in parentheses, times x. X is just that argument. It drops to the bottom. All right, my second term. So I have 1/2, so we're going to have 1 over 2 natural log of 8 times that argument, x minus 3. All right, you would use chain rule if you needed to at this point, but the derivative of x minus 3 is just 1, so we don't need to put anything else. And then, of course, minus 0, that's a constant. Remember, it equals 1, but even if you didn't know that, it's still a constant. You don't have a variable in there, so the derivative of a constant is 0. Now, that answer is perfectly acceptable. However, I'm going to teach y'all how to get a common denominator for this. So the common denominator would be 2 natural log of 8 times x minus 3. That just comes from all the different products, or the product of all the different things we have in the denominator. We have the 2, the ln 8, the x minus 3, and then I've already have the ln 8 for that term, our first term, and then we have the x. Okay, so looking at that first term, the only thing that would be missing would be, let's see, the 2. I can't really squeeze it in. We'll just put it here. The 2 and the x minus 3. Okay, so that means that 1 needs to be multiplied by 2 times x minus 3. So that goes in my numerator. All right, plus, with my second term, it looks like the only thing missing would be an x. So we're multiplying the bottom by x and the top by x, so plus x. Okay, so you can distribute that 2. So we have 2x minus 6 plus x all over that denominator. And then combine your like terms. So let's see, 2x minus 6 plus x. So 3x minus 6 all over the denominator. Okay, now even though we could factor out our GCF in the numerator, which would be 3, I don't think it's going to help cancel anything because that would give you x minus 2. So I think that's all we need to do for our answer. So let's put it in and see if that is correct. Okay, and it is. So we're done with that section. Stay tuned for the next one.